Hello, everyone. Welcome to Session 2, Feasibility Analysis with RETScreen Expert at the RETScreen World Conference. RETScreen's Feasibility Analysis module is the most comprehensive product of its kind, allowing engineers, architects, and financial planners to model and analyze any clean energy project. In this session, we'll hear from Kevin Bourque, who will discuss recent additions to RETScreen's feasibility analysis capabilities. Following Kevin, Stephen Dixon will show you how to prepare rapid energy audits for buildings and factories with RETScreen. Closing us out is Michael Ross, who goes over managing a portfolio of power project investments with RETScreen. Now let's turn things over to Kevin and hear about additions to RETScreen's feasibility analysis capabilities.
Hello, everyone, and thank you for joining me in this session. My name's Kevin, and I'm really excited to show you some of the new features in RETScreen Expert version 9 and some other features that you may not have seen before. As part of my role on the RETScreen team in capacity building and support, I get the opportunity to meet a lot of people, to help people out, to write, and to really understand how people are using RETScreen. Through that work, I also get to see some really innovative things, and I get to share some maybe lesser known sort of features or tips or things in RETScreen that can help and accelerate the way you use it to really streamline that. And today I'm going to focus mainly on the feasibility analysis in RETScreen. And so on this project workflow circle here on the home worksheet, it's this bottom half of the circle here. So we'll be focusing on that for most of the. So as you know, as was mentioned, there's lots of new things, including each of these buttons here actually open a project. So I'm going to click on this transportation one because transportation is a relatively new model. It was introduced a little while ago, but we've added a lot to it since then. So when I click on that, this example shows up, and you can see here our facility in Varennes, Quebec, just outside of Montreal, where we have the climate data and the facility information on the facility worksheet for the benchmark, and so we can start describing some of the information here. And so this is the transportation model, and you'll see here that just like any of the facility models or power models, we have a menu where you go from left to right, selecting the various items. And you can see here in my transportation model, in this case, I'm switching from a car that uses gasoline to an electric vehicle. And in RETScreen, we've added a bunch of databases. So here is a product database. If I click on this little basket here, and you can see we have all sorts of types of vehicles, from electric to plug-ins to SUVs and vans, and all sorts of different brands and years of manufacturers. And there's quite a lot in here. So feel free to use this. It has the fuel efficiencies for all the different types of vehicles and the different years. And when you click on OK, all that data gets pasted into RETScreen. So that's one more tool for you to have in your arsenal when you're doing transportation vehicle analysis. So that was method one. You can also look at not just changing a vehicle, but a whole fleet of vehicles. And here we can see many different vehicles here. So we have some cars that are being transitioned to something that is more efficient. We have some pickup trucks that also are being driven a little less and doing fuel switching. And we have a bunch of different opportunities, and these all stack. And in RETScreen, of course, we provide that summary for you. And then all of the cost and emissions and finance information follow just as you normally would use in RETScreen. So for example, here we have on the cost sheet all the incremental costs from there in level 1, 2, or 3, just as before. And similarly with the emissions, we can calculate the emissions reductions from changing over a fleet, and similarly with finance and so forth. On the data worksheet, you can also track the consumption and the travel distance of these vehicles and create a database of transportation, including all the emissions and the emissions reductions and fuel reduction for your vehicles and for your fleets. And of course, all of this also rolls up into the portfolio. So RETScreen does provide a comprehensive database and tool to track your fleets and vehicles, just as RETScreen has done for facilities and power projects and so on. One other thing is, just as a reminder, for every one of these models, we are continuing to add to our library of e-learning videos. And so we've recently added transportation videos. If you click on the e-learning button here in the menu, when you're on the energy worksheet, I have here some transportation videos that you can go and visit to help you out. The other thing that we've added in RETScreen is we've expanded some of our cogeneration and district energy archetypes. And so I'm going to go into here. And you'll see, actually, now that I have this open, in addition to the transportation model, we have a lot of transportation archetypes. So you can see here we have lots of different types of vehicles. So trains, moving transportation or fleet management over to trains. We have marine and aircraft, for example, for the military. We have all sorts of different types of measures that one can use to reduce the energy and emissions associated from transportation. So for example, you can look at fleets, just as we just saw in that other example. So go ahead and explore these. Spend a few minutes on your own when you have a chance and explore these. They're lots of fun. And we also show these in those videos I mentioned before. If instead of transportation, I go to the power, heating, cooling model, this is where we find, as I mentioned before, some of these very large cogen and district energy systems. So you see here, I have hospitals, I have a university. If I go to combined heat and power, we even have a, pulp and paper industrial site, and even a district energy system. So if I click this here, and I'm going to load this archetype, so I have power, heating, cooling, and I have this district energy heating system. I click OK. This is something that maybe people aren't aware of or you haven't seen in RETScreen. When I load up this archetype, similar to before, I have the location worksheet, the facility worksheet, and now on the energy worksheet, I can start having groups of buildings. I can add maps here and the layout of my heating network design. I have the piping and all the buildings that those are connected to, and this can get quite detailed. And so this power and heat load is met by the steam turbine, and there's a lot of tooling in here to let you do sort of very, very large scale district energy networks in RETScreen at a feasibility level. Another one of the archetypes that we have added in the models is what we call our power storage and off-grid system. So if I click here, you'll see here that I have photovoltaic or wind turbines. And under this description, I have all sorts of different scenarios or topologies that you can set up a off-grid or storage system. So for example, going from a genset, say a diesel generator, to the photovoltaics and a battery system, or keeping the genset in the proposed case, and all sorts of different types of off-grid storage, including extending the grid or comparing that to having battery storage, on-grid battery storage, and seasonal chalets and livestock irrigation, and all sorts of interesting ones there. So if I select one of these, let's load one of these as an example, and let's scroll down here let's go to this town of Simcoe, and suppose maybe we're going to do grid installation over here, and I click on OK and calculate. RETScreen will load up that archetype. It'll load up the facility information and the climate data, and we'll have a full analysis using the RETScreen's archetypes from there. So again, the location, the facility worksheet. Now here we have benchmarks for off-grid and storage scenarios. So you can see where the costs are and the benchmark and the energy production cost for off-grid scenarios. And if I go to the energy worksheet, I see here that I get to define what my load is, what the inverters and batteries are, and how I'm going to meet those with the photovoltaic system. And you can see I can have lots of different types of systems. Once again, we have videos for those power, storage, and off-grid. So go see those. And also, we have our database and our cost database, which keep getting updated. So we keep adding new features to all the models. So for example, here in the photovoltaic model, we have this bifacial cell adjustment factor, and that's new. We've also added multiple stages to air compressors. So in all of our models, keep looking out for improvements and keep looking for those. Returning to the virtual energy analyzer, this falls under the category of things that I use all the time that people may not be aware of. And these are these individual measure archetypes. So I've shown you some transportation archetypes off-grid in many other videos and training sessions. We've explored a lot of the other types of archetypes that are available there. But the individual measures really narrow down not on a whole facility, but just a partial part of a facility. So for example, looking at schedules or looking at just lights, I have here a lot of different energy efficiency measures that I can apply to lighting. So for example, switching to LEDs or switching to LEDs before my existing fluorescent lights at the end of their life cycle. There are ones here for compressors. There's ones here for all of the individual energy systems to look at just those as a component. There's dozens and dozens and dozens in here. I would strongly encourage, if you haven't explored those, look at them. They're great for, hey, what if I just want to change the light bulbs in my facility, or my windows on my building need to be updated, and so forth. So there's a lot of different things here, from variable frequency drives and floating head pressures and changing schedules and putting in smart meters and all sorts of things. So go and check out the individual measure archetypes if you haven't already. I'm going to switch now to an archetype that we've shown often, and that's our office archetypes, our full facility. But something that's new is our deep retrofit. So I'm going to load up this deep retrofit archetype, and I'm going to click on OK for this. Okay, once the archetype is loaded, as usual, I have the climate data on the facility. I have the basic information about my facility. And so remember, the idea with an archetype isn't to say that that building is what yours should be. It's really a shortcut to get you started with doing all the data entry. So using an archetype, you can usually save at least 50%, sometimes 60, 70, even 80% of the data entry task of modeling your facility. And so once you load an archetype, it's now you have the opportunity to start adjusting and adapting that archetype to your own. So one of the first things you might do is say, well, fix the size. So suppose this was my building, and instead of my building being 4,500 square meters, which is the archetype, perhaps mine is 5,500 square meters. So I'm going to type that in on the facility worksheet in the benchmark section. And so RETScreen recalculates some of the outputs on the fuel consumption based on what has been modeled on the energy worksheet. And let's go there now. So I'm going to go to the energy worksheet. And so I have here my full facility. And one thing, I wanted to show a couple of things here. So the first thing is, if I go into my heating systems, okay, so for our deep GHG retrofits, we're switching from natural gas to electricity. If I have a heat pump system in here, a new little button appears here, which is our ground heat exchanger tool. So if I click this tool now appears, which allows me to start sizing my heat exchanger, give some information about the soil, and RETScreen will come up with a preliminary cost for that. So this is available now right with the equipment. It still is also available in the cost sheet. So if I go now to cost and go to level 3, so some of you may know this, when you go to level 3, there are project-specific costs. You can see here our ground heat exchanger, and that button is still there. So we've made that a little more prominent by bringing that right at the equipment level. So that tool is there, very helpful. Highly recommend if you haven't used that. Now back on the include measure page, an important part of deep carbon retrofits, and something that we've added to RETScreen, is this offsite renewables. So if I go into the menu here on step 4, optimize supply, you'll see this is a new item here, offsite renewables. And you can see right here the offsite renewables. And when I go into it, RETScreen asks you how much electricity is required and what the source of that electricity is. And then in RETScreen, when I activate that, the emissions are updated. So for example, without offsite renewables, if I go to this emissions worksheet, you can see we have a 91% reduction in our GHG emissions. Now I'm going to go to the energy. I'm going to click on this offsite renewables. We now are purchasing solar energy or renewable energy credits. And if I go back to my emissions, I now have a net zero scenario. So this is important that we've added these offsite renewables so that anywhere in RETScreen now, you have the opportunity to look at net zero modeling. Remember also, this falls under the category of tips, is this comparison section really is a really great tool to help you calibrate and validate your model. So this comparison section has a summary of the fuels, so your base case and your proposed case, and you can enter here, if you select base case, you can put in your actual utility consumption, your historical data from your bills, and RETScreen will help you determine just how far off your model is, so you can start calibrating, and so you can validate whether you have properly modeled your facility or not. One thing I'm going to do is down here, since we are doing heating, we have a new tool called the thermal energy demand intensity. And if I click on this, RETScreen calculates the thermal energy demand intensity. The first thing it asks is, well, what's your facility size? Now, remember, I changed my facility size on the facility worksheet. So if I click this button, it will update to the 5500, not the 4500 from the archetype. So let's update this one as well. So now we've updated all of this information on the comparison section. And you can see here what the thermal energy demand intensity is in RETScreen. So that's a useful calculation that we've included in the software. Another thing I wanted to show that's new in RETScreen is, well, we've loaded this archetype, right? And we've started adjusting some things, but we've only adjusted the size, the floor area. We haven't gone into each of the individual elements and submodels of our facility. But we do have this tool here called a scaling. So let's take this tool, and we can see here that RETScreen has what the facility archetype, the facility size of the archetype as loaded, and we get here to add what our actual facility size is. So if I click this button, it'll update from the facility worksheet, which it already has. So here it's 5,500 square meters. And you can see in here, RETScreen has shown us what the utility consumption is, what the fuel consumption is for the archetype, and what it would be if it was scaled according to the scaling factor. So at 5,500 square feet or square meters, we're 22% larger. And so RETScreen will scale all the fuel consumption, taking that into consideration. Now, by default, RETScreen will use a linear scaling method. However, you can also change that scaling component. So for example, it could be a sublinear. So for example, the building consumes relatively less and less energy the larger it gets. So for example, certain scenarios, depending how the building is, as it gets big, so as the building doubles in size, it might not consume twice the amount of energy, but conversely, it might be super linear. So it might consume more energy, depending again on the type of facility you have. But again, RETScreen uses the linear by default. And when I click OK, this is for reference, and RETScreen will keep this information in its memory. So now when I click on the scaling update, all that information is kept here. That's by clicking on this OK button. If I click on this Copy to User-Defined Model button, RETScreen will load this into the user-defined model. And so I'm going to do that now. So I'm going to click on Copy to User-Defined Model. Everything I have in this model is kept the same. RETScreen's calculating. And now you'll see I'm in the user-defined model. So you'll see here that I'm in energy, and RETScreen has taken that overall fuel consumption that I had from that scaling. So the whole model before, which had all those elements and different components of my office building, are now distilled down using that scaling tool to the scaled fuel consumption for natural gas and electricity in the base and proposed. So the proposed case is net zero, so I don't have any gas or electricity consumption directly from my building. So that's one thing that I wanted to show you here. The other thing, now that I'm in this user-defined model, is we have started to add the ability to link RETScreen to other modeling tools. So for example, here, if I click on this Energy Plus, Some of you may be familiar with Energy Plus or other modeling tools that offer different features. Energy Plus has a different energy modeling engine. And so we can import that data directly into RETScreen. So if I click on this Energy Plus import, so I have here an output file from Energy Plus. I'm going to select, this is a base case, and I can also select the proposed case. And RETScreen asks me, do I want to break this down by the end use fuel consumption or actually look at the various loads? So let's look at the end use loads. I'm going to click OK. RETScreen asks me what the fuel rates are. So if we're changing fuel rates, we can put that there. And when I click OK, RETScreen will load the output from that Energy Plus model directly into RETScreen. So this is a new feature in RETScreen that has a lot of potential. And so you can see here, we have the cooling load, we have the lights, we have all the electrical load from the equipment, from the plug loads, fans, pumps, heat recovery, heating, hot water, and so on. So we have here in RETScreen all the output from a different model, right? Now the advantage is now I can use RETScreen for the cost, emissions, finance, data. This is a great tool if you're working with an ESCO or a consulting firm and they have other tools that they may want to use. You can use the user-defined model to include RETScreen as part of your portfolio and leverage the rest of RETScreen's tools for those other types of analysis. Another thing that we've added in this user-defined tool is you'll see here a new button that says water. So in the past, we've tracked water in terms of how much energy it takes to heat water, for example, but this really is a water consumption tool. So we look here at the flow rate, we would put in how long, and RETScreen will calculate the water savings, so the actual amount of water and the costs associated with that. So that's a new feasibility tool that's related to energy, but that is new in RETScreen. So that's in the user-defined model on the energy worksheet. And I'll show you how to get there. If you go to the facility worksheet, remember when you select your facility type, the last one down here is the user-defined model, and that gives you the ability to use the user-defined model on the energy worksheet. The last thing I want to show you are some features that I use very often that may be useful. If you go to the file worksheet and click on the open button in the left-hand side, you'll see here another button for Energy Plus. So not only can you import the outputs from Energy Plus into RETScreen, you can actually start your file starting from an Energy Plus file. So that's a useful feature. Another thing is this file example 1 is our own facility, the Canada Energy in Varennes facility from NRCan. And this is where a file that we try to keep updated all the time that has a lot of the new features in it. So when I click on this, I'm going to load the Canada Energy Varennes example in RETScreen. And one thing I want to show you is this is a complete example, including, of course, all the climate information, the benchmarking, not only for fuel benchmarking, but emissions benchmarking as well, the full energy model, as we showed before, the cost, emissions, and finance, the data and analysis worksheets, including all sorts of graphs, which you can look at, and the report, which I haven't mentioned yet. So RETScreen includes this automatic report writer. And some of you may not have seen yet this custom worksheet, which provides a dashboard, is a presentation and reporting tool. So each of these sheets can be fully customized with the various graphs that are included in your analysis. This custom worksheet includes some features now where you can include information from the feasibility analysis, including the energy and comparison tool. We have the end use graph and more. So these are great tools to use as a kiosk, as a presentation, and as I said before, are completely customizable by clicking on this format dashboard. So that's a whirlwind tour of a lot of the new things that have been added in RETScreen. There's way more that I could show in the space that we have now, but I look forward to your questions during the Q&A and by email. Thank you.
Thank you, Kevin. Are you interested in preparing rapid energy audits for buildings and factories using RETScreen? Yes? Then let's make our way over to Stephen.
Hello, folks. Welcome to my session in which I'm going to be sharing some ideas around doing rapid or quick energy audits using RETScreen Expert. This kind of draws upon my experience over probably 40 years of energy management work. I started off over 40 years ago doing energy audits, and I've evolved the methodology that I like to use for doing audits either quickly or over extended periods. I call it the 7 steps. It turns out that we developed this probably 30 years ago, but today it's actually very relevant because it is also 7 steps towards net zero or low energy or low carbon. So the path to net zero, I guess you could call it as well. It starts out with the first phase of the 7 steps is working through understanding the present usage of a facility, which begins with cost comparisons, understanding when energy is being used, where it's being used. And I'll take you through each of these steps in a bit more detail and show you how RETScreen provides great tools for executing the steps. The second phase of the audit is to essentially look for opportunities, but also prioritize ones that you've probably identified within the first 4 steps. And I always say waste, efficiency, and then supply in that order. Eliminate energy waste, improve the efficiency of the systems, both operationally and technologically, and then eventually look at the supply side of things. And that's where many people ask me, Steve, where do renewables fit? Well, they fit into step 7. We have to get there first, make sure that we understand how the building uses energy and we've reduced its conventional energy use, and then we can apply those renewables. And to me, that produces the best overall result in the end. So RETScreen is a complete toolbox. And I truly mean that. I did a workshop a little while ago. There was a gentleman there. And after the workshop, he went away, started to use it on audits that he was doing in his practice. And he called me up about a week later, and he said, Steve, I can't believe how this tool set is all there, right? He said, everything I need to do in an audit is there. I can contain all the information. I've got places for notes. I can do my financial analysis, my costing. I can actually come back afterwards and do the performance analysis to verify that the savings are actually there. So RETScreen provides all of that in one convenient toolbox. I always start out with performance analysis, where I start out with the data on the way the building uses energy. I work towards benchmarking, and then I work around towards identifying projects, understanding where the energy is going in the facility, and finally building the business case as required by the customer for my particular audit. So that cycle in the center there works very well for doing an audit, and RETScreen has all the facilities to do that. So we begin with step 1, which is understanding the consumption and the cost of energy. And it's a question I commonly ask people at the beginning of an audit: how much do you pay for energy? And I judge how aware the organization is by how long it takes me to get the answer. And then I say, well, how much do you use in terms of gigajoules and kilowatt hours and cubic meters and so on? And again, I understand a little bit about what they're aware of through how long it takes me to get the answer. Ultimately, I work towards the idea of what the price is, because at the end of the day, if I do an audit to determine savings, I have to be able to understand the price to apply to calculate those savings. So RETScreen has great tools for being able to chart out, plot, examine, display what's being consumed historically, and even beginning to relate it to what's driving it, in this case, weather. We can do year-over-year comparisons, and we can drill right down to cost comparisons to year-over-year. So all the tools are there. We simply have to go to the bills, which is where any good energy audit starts, right? Grab the data in terms of the consumption and the cost, and ultimately the price, drop it into RETScreen. It's there for use and other times within the audit. So that's the starting point, is with what the building is using today. The next step I always like to move towards is understanding how this building compares. And we're going to do 2 things in comparison. We're going to compare ourselves to ourselves, compare yourself to ourselves, but we're also going to compare ourselves to others. In fact, comparing to others is going to come first. That's what traditionally we call benchmarking. So the idea here is that we're looking for better practice in order to determine better performance. So we have to understand current practice and current performance, and then move a facility towards better practice and eventually best performance, if that was the goal. The idea here is analysis. what we want to do is we want to take data, which we've probably already measured through utility meters, and analyze the heck out of it, and really understanding what it's telling us about the way this building is using its energy, both in a static framework, that is a kilowatt hours per square foot per year or per unit of production in an industrial facility, but ultimately how that changes over time. RETScreen has a great set of benchmarking tools, both at an individual building level, but also at a portfolio level too. I'm going to focus on a building, but suffice it to say, if you do 50 audits, the portfolio analysis tools in RETScreen are great for being able to display the results of those 50 audits en masse, comparing them one to the other. Here we're simply comparing one building's energy consumption in its base case, the way it is today, to a standard, which is drawn from the list in the upper right-hand corner here, the benchmark database within RETScreen. So all that's there. All you have to do is put your energy in, your square footage. You can go to the database, pull it out, and make those comparisons, and even start to set targets. If the building owner, facility owner has a target, we can put that in there and determine what that means in terms of what our outcomes are going to look like. This is where I get really excited, because then I start to take the gas, the electricity consumption here. Here I have electricity consumption in an industrial facility, and I'm comparing it to the weather outside, how cold it is outside. We represent that as degree days very nicely within RETScreen. All the tools are there to be able to pull the degree days in, calculate them for any balance point temperature. If you're an aficionado of balance points, you'll understand what I mean there. Also bring into play the flow through the plant. This is the plant that was moving a product, so the flow through the plant becomes important. Now, I'm not doing this to monitor going forward the projects. I could use these same tool sets afterwards to verify performance after an audit was done. But what I'm doing here is to figure out how the building or that facility got to the way it is today. So I can go back to 2020 here and see that in that baseline period on the graph on the right, that's their baseline. Then their consumption moves upwards. So they're actually using more than they did. So the state of the building today was not the same as it was 3 years ago. And I need to understand what causes those changes, because that actually is part of doing the audit. Many times, those changes are unknown to the facility, and we've actually discovered opportunities. In one industrial facility, very similar to this one, we actually discovered that they'd moved to a third shift, and then they were using only about 3 or 4 hours of that third shift to make up production. They left equipment idling. It really wasn't idling in terms of energy, and that upturn allowed us to quantify about $250,000 savings opportunities for simply just turning things off. So you can quickly get to this stuff, rapidly audit this facility. There's another example where it was a small food manufacturer, and we'd gone in, and it was funny because they said, well, we need to do an audit because we're not seeing the savings from our lighting retrofit. Well, it turned out that there was some obscuring factors, like there was a compressor control malfunction. It turned out that they had a heater that was turned on in part of the plant they didn't even know about. I actually was able to tell them from the slope of this line how big the heater was, and then they went and actually figured out how to control it better. And then eventually they were able to see the savings. So the audit wasn't to find the lighting savings, it was to find the benefits of what was done before. Interesting. Quickly able to do that with RETScreen and the tool set contained in. Another one of my favorite areas, when energy is used in a facility. When is it? When is that energy used? Well, I love to go, and I've done this since 1983. I go and I get the electricity demand, the power, that is, for the facility on a minute by minute, in this case, 15 by 15 minute basis. And RETScreen has the tools to pull that, what they call sub-daily data in, and plot it really nicely on these graphs. I can favorite graphs. If I'm doing an interactive session with people, I can do heat maps. I can do low duration curves. I mean, there's so many things we can put on the graphs here. But what I love to be able to do then is overlay the parameters of influence, things like, in this case, cooling degree days, and see how warm it is outside is driving the electricity demand for that building. Again, all of this in the same toolbox. Understanding where energy is used. Any audit, I was taught years and years ago, the most important thing to do in an energy audit is to understand where it's all going. Make sure that what you think the building is using is what it used historically. So RETScreen gives us the tools to, in fact, start to break down the consumption. This allows us to focus on the bigger areas of use, right? Or maybe some of the ones that we weren't aware of. Once we do the calculations, we realize how much plug load is consuming in energy. And this is not fictitious. We've seen buildings that once you go through that inventory process, which you can do with RETScreen very nicely, once you go through that inventory, you discover a lot of opportunities in things like plug loads, things that are turned on, and you don't even realize it. So RETScreen provides you with the ability to develop a base case inventory. and then produce those pie charts. There is no meter that can measure this, but RETScreen has the ability to create those nice pie charts that become a key part of an audit because it focuses people on what am I going to look at here? I'm going to look at space heat. I'm going to look at lights. You know, where am I going to put my emphasis? And the other thing this allows me to do is to make sure that if I'm going to go in there and I'm going to change the lights, that my assumptions around what the lights are using today fit within this overall puzzle, right? Meaning that I don't estimate savings that are greater than actually is being used today. So it actually improves the quality of an audit, no matter how quickly you're doing that audit. So the base case, inventory and the feasibility analysis then forms the basis for the proposed case, which is the way you want it to be in the future. So ultimately then we move towards the second phase of this quick energy audit where we're looking for savings through waste, efficiency, and supply. And RETScreen set up to do this, right? The feasibility models in RETScreen are really set up to do waste, efficiency, and supply considerations. So as I said before, you know, getting the waste out, energy we don't need to use, improving the efficiency, and eventually moving towards that supply side of things. Now, one thing I'll always say in any audit you do, any energy assessment, any search for opportunities, is respect the need, right? We always have to respect what that building needs to use energy for, and that could be defined in terms of heating or cooling, air power, fluid flow, ventilation, illumination, anything. We really need to understand what it is and document that need. When you do existing building commissioning, which is kind of another practice, you want to start with the current facility requirements. Well, that is properly documented and never compromised. Now, the other thing that I like to say at this point, though, is, you know, are we using energy that we don't really need to use, or are we using a form of energy that we don't need to use? So at this point, by documenting what we need to use, I think we can do a pretty clear determination of what's really valid, and that becomes one of the first opportunities we may go after. So getting rid of waste, matching that need, downsizing energy use to what's appropriate. So here we're looking at things like turning things off, turning things down, and controlling things, making sure that things aren't running. You know, to be honest with you, every energy assessment that I've been involved with in the past, you know, and even lots of existing building commissioning studies that are done today or investigations, what we find is simply scheduling things properly is still probably one of the #1 opportunities, not just things like leaks, compressed air, steam in industry, but just the way lights and fans and pumps and things are actually operating, making sure that we only operate them when we need to. If we can't turn them off, can we turn them down? And that's where things like drives and things like that come in. And making sure that our automation, controlling things, just because we have automation, doesn't mean we're actually going to make those opportunities. We're going to be doing it right. And that's where we find lots of opportunities. Just like in an automation system, RETScreen is really good at dealing with schedules and temperatures and things like that. So making sure that if we've got ventilation, if we've got building envelope heating, that we apply the right schedules and we can test proposed schedules for in this particular case, the office. So looking at changing temperatures for the same operating schedule. So we can then model those improvements. I actually worked with one building operator a number of years ago in an older version of RETScreen. He used to have a model of his building. When somebody came to him and said, what can we do to improve? He would actually test out things that he could do in his building in terms of changing the schedules. If it looked like it was worthwhile, reasonable amount of money, energy be saved, he would then implement that with the automation. But that's certainly part of what we do in an energy audit. We can certainly quantify things like steam leaks. RETScreen has built-in steam tables that has the tools to be able to go in there and actually quantify. In this case, on the screen, I'm showing you 1/8 of an inch steam leak at about 250 pounds, right? You go, what's that worth? Well, it's 1,292 gigajoules. At $10 a gigajoule, that's $12,000. That's worth doing something about. But again, in a rapid energy audit, we can catch these things and we can quantify them very quickly. I always say that an idea is great, but an idea with numbers attached to it is even greater and has legs and will probably gain some attention. Maximizing efficiency beyond waste, then making sure that we get the most out of the systems that we're using. And that can come down to replacing things like the bottom bullet on the slide here is replacing equipment, more efficient equipment. But it doesn't begin there. It begins with looking at how we're maintaining and operating the equipment that we have, making sure we keep things clean, making sure that we're tuning up our boilers. And we can model improvement in boiler efficiency or furnace efficiency within RETScreen quite nicely, making sure we're sequencing properly, right? There's a pump and a fan and an air compress tool in RETScreen that we can go in and we can use to optimize the operation of those systems, improving their efficiency as a result. There's an example of a lighting retrofit that we can do. So again, we can jump in, say, okay, I've got this idea, I'm going to change those T8s to LEDs. Boom, I can generate the numbers. And the cost database over here allows me, without even going to a contractor, to estimate the cost in my rapid energy audit very quickly. So the tools to estimate savings that we have today, or sorry, estimate the consumption we have, what we can save, and then what we can save in terms of dollars as well, and then the cost of those things. So RETScreen has all of that. It's very quick. If you're doing audits with spreadsheets, I would really seriously consider doing them this way. I did a RETScreen expert workshop this week, 3 days. Probably half the people in the room do energy audits. All of them were converted to using RETScreen Expert as their audit tool of choice. They were using spreadsheets before. All right, that's pretty significant. Compressed air systems, looking at optimizing a complex industrial compressed air system. There's a significant amount of savings there. And it's not just about leaks. It's about how we control the system, how we stage them, the compressor types that we're using. All of that can be taken into account in a RETScreen model. All right, well, that was waste and efficiency. And I just want to point out, and again, RETScreen gives you the ability to do this. We can look at both operational means of improving efficiency or reducing waste, or we can look at technological means. So those schedules, well, that's control, manual control, or maybe scheduled automatic control. We can look at operating conditions. We can look at our compressor. We can look at where it's getting its outside air from, because outside air is is already denser. Therefore, we're going to get more efficiency out of the compressor. That's an operational means of improving compressor efficiency. And eventually, we can model putting a variable speed compressor in this situation. So there's lots of ways within RETScreen to model all these different types of standard opportunities. So waste and efficiency, operationally and technologically. And finally, optimizing energy supply. Optimizing energy supply covers all the things on this list. Heat recovery. RETScreen has in many places, there's probably at least a half a dozen places in systems in with RETScreen where you can model very quickly the heat recovery potential. The beauty is if you do your rapid energy audit by going through and identifying where all the energy is used in the base case, then you can simply go through and say, is there an opportunity for heat recovery on this hot water? Can I put a drain water heat exchanger in? If I can, yes, I'm going to dial in a 60% efficiency, literally with one number, and we can pull the cost of that from the cost database. We now know what that opportunity is worth and probably what its financial return is to the organization as well. We can do on-site generation, we can do renewables, photovoltaics, geothermal, all those things. RETScreen actually started out as a renewable energy software, and the renewable energy models in RETScreen are, I'm going to say second to none, but they're certainly up there with pretty much any of the ones out there. And being integrated into a package like this, when you do an energy audit, you don't have to go to their software package to analyze this. You can simply embed within your building a renewable energy system or even on-site generation, and then integrate that into your report, which is where we're going next. So waste, efficiency, and then supply. Heat pumps, big thing today with decarbonization. RETScreen has an incredibly good model. A lot of people aren't aware of this model. It's in the power heating cooling module of RETScreen. Many people work in the feasibility of the performance, but in the power heating cooling, you can actually model a heat pump very nicely. In fact, if you've got the historical consumption in the building, you can use this tool to preliminarily size, I'm going to be cautious there, but preliminary size your heat pump, and then cost out and show what the carbon benefit is for that decarbonization, as it were. So lots of tools available, things that are buried. Many people say, I don't know everything that's in RETScreen. I'm going to tell you, I know I haven't used all the tools in RETScreen. I've used a lot of them, and I use them for doing audits and assessments very quickly. We actually do energy treasure hunts, which is kind of like a rapid energy audit, and this is our tool of choice. We can model solar, hot water, photovoltaic systems, right? And ultimately, I want to be able to tell people about what my audit has found. So that's where being able to present results and making a compelling case for action is very important. So the first thing we see in RETScreen is that we can go in and we can actually take a look at a summary of all the measures we found in the building. In the left-hand pane are all the systems. In the middle pane, that's all the energy that's used in those systems. In the right-hand pane, that's all the savings that are available, the costs, the O&M savings that might be associated with the energy savings, and a simple payback measure, and the ability for me to check boxes here, and that is I can sit with a customer in my quick energy audit and I can identify opportunities they want to execute, put them together, and then take that package of opportunities forward into a financial analysis. I can also very quickly gauge the carbon reduction for my audit. I can express it in terms of simple things like taking light cars and trucks off the road or not using them. No matter where I am in the world, I can bring the carbon factors. Those are all embedded in the RETScreen. So I don't have to go searching for a carbon factor to figure out what my audit is going to reduce in terms of carbon. It's all at my fingertips in this package. And then if I want to create a very, very compelling financial case or business case, then what I'm going to do is I'm going to use the level 2 financial analysis in RETScreen to be able to produce these things like cash flow, cumulative cash flow diagrams, and calculate the net present value of this project. And also do things like look at financing of the project. So if I want to borrow some of the money, pay some interest on it, that project still turns out to be a very compelling, good project. So ultimately, we've got everything. We started out with an idea at the beginning of our audit about what we could do, and we worked our way through to basically, a top-notch business case, financial analysis case, which any financial officer in an organization, I think, would be quite impressed to see. And at the end of it all, we can hit a few buttons and end up with a pre-printed report, right? So we don't have to go and spend a lot of time writing reports. Now, if you want to customize things a little further, there is a custom dashboard where you can go in and create custom views. So maybe we wanted to examine 4 different scenarios on this one building that we're auditing. So we can create a custom view of what those 4 scenarios look like, and then couple that into our custom report. Ultimately, we can take the results of these rapid audits and deliver them in a compelling way. So it's not good enough just to do the audit. We have to be able to communicate as well. And RETScreen Expert provides, I think, amazing presentation tools for actually getting that result in front of somebody who's going to make a decision to do something about this audit. On that note, I'm going to thank you for your time and your attention today, and go forth and audit with RETScreen Expert.
Thank you, Stephen. Let's now learn about managing a portfolio of power project investments with RETScreen. Take it away, Michael.
Thanks very much for this opportunity to present the management of power projects with RETScreen's portfolio functionality. In today's presentation, I am going to be introducing the use of RETScreen's portfolio functionality with power projects. Many of you will be familiar with its use with buildings. Here, I'm going to use its functionality with power projects, specifically those found in a new example portfolio that's going to be appearing in upcoming versions of RETScreen. I'm going to look at some benchmark analysis examples where I'll compare technologies against the expectations we have for those technologies. I'm going to look at some performance analysis examples where I'm going to look at the tracking of measured or monitored operation of already built projects. And then I'm going to look at some feasibility analysis examples where I'll compare proposed projects on the basis of their profitability, scale, and GHG reduction costs. So just an overview of the power projects portfolio. It includes information from 20 real power projects located in the province of Alberta, Canada. These include renewables projects as well as conventional power plants. The monitored data or the performance data is publicly available information from the Alberta Electric System Operator. That includes daily electrical output data for multi-year periods for each of these 20 power projects. In the feasibility studies, we've taken this measured real electrical output data and extracted the capacity factor, that is the average output of each of these projects, from the performance analysis. And we've combined that real information with some assumed information about project costs and fuel costs, assuming that we were to build these projects today. So this is hypothetical. These projects actually do exist in the real world. In the feasibility studies, we're saying, well, let's say we had to build these projects today. What could we expect for costs? And as well, what could we expect for the rate being paid for electricity, which we've based on the power pool price in Alberta over the last few years. And I should point out that the power pool price has been very low in Alberta for the last few years. So this might not reflect the reality of projects, which might have long-term offtake contracts at fixed higher prices. Within the power projects portfolio, projects are grouped by technology, capacity, whether they're renewable or non-renewable projects. And there are dashboards already prepared for benchmark performance and feasibility analyses. So what's the use of this example portfolio and who might it be interesting to? Well, it's a demonstration of the use of the RETScreen portfolio functionality, specifically with power projects. There's been a lot of use for building facilities. This shows it for a different application, power projects. And this may be of interest to companies that are comparing potential energy project investments. And indeed, that's how I've seen this used. A client who had a large number of renewable energy projects spread across the world at different operating companies wanted to have a way to compare them in terms of their profitability, scale of investment, and GHG emissions reduction costs. It could also be of interest to a utility or an independent power producer that wants to track project performance and feasibility. No doubt they might have access to more complicated and in-depth tools, but I think there's a role for a simple tool that provides a high-level overview of all one's projects in a portfolio, including both performance and feasibility. Could also be of interest to a renewable energy solutions provider investigating how their offerings compare with other technologies, and researchers and educators working in power projects. So I will now switch to the tool just to show you how this project looks, or rather how this portfolio looks. So we see here in this main pane the 20 projects that are contained within this example portfolio. If I look at the map view here, for those of you who are not from Alberta, you can see that this is all in the province of Alberta in Canada. And if we zoom in a bit, we can see most of the projects are actually in the southern half of the province. The green squares are indicating the locations of the project. So here's a hydro project. Over here is a wind project, another wind project. Here's a solar project. So you can see the map view of these different projects. For the groupings of the different projects, when we open up this pane on the left, we see that there are different groups that divide the projects up by technology type, by their capacity, by whether they're renewables or not renewables, and other criteria. In terms of technology type, there are further subdivisions into gas turbines, photovoltaic, steam turbines, wind, hydro, et cetera. And even further subdivisions, for instance, in photovoltaics, the projects are divided into those that track the sun and those that are fixed in place that don't track the sun. So that will allow us, for example, to see if the performance benefit you would expect from tracking the sun is consistent with the monitored data we have from these projects. I'll first look at benchmark analysis, and there's a lot of different things I could look at, but what I'm going to focus on here is identifying which projects are providing cheap electricity and which projects are providing expensive electricity. And keep in mind, once again, that while we have real performance data, the feasibility studies and the benchmark studies are based on assumed costs and assumed prices paid for electricity and may not reflect the reality of these actual projects. So turning to the dashboard here, in the benchmark analysis section, I will start by looking at all power plants. And what stands out here is an outlier in terms of really expensive power. So these blue bands here are the energy production cost, the range of expected energy production cost in dollars per megawatt hour for the different technologies. So we see that there's one hydro turbine that produces power at a higher cost than one would expect. And it's in fact the Brazo hydro project we can see here. And it costs about 37 cents per kilowatt hour to generate power with this project under the assumptions that we've made for this portfolio. So that's definitely a high cost provider. We also have under the gas turbine, a simple cycle gas turbine. And this makes sense. It's a peaking plant. It operates relatively inefficiently. So it's only operating at high times of peak demand when electricity prices are high. One of the wind turbines is also a high cost project. This is the Bull Creek #1 project. So it stands out from the other wind turbine projects as being a fairly expensive one. In terms of low cost, there's a reciprocating engine project that's also an outlier. It's cheaper, at least under this set of assumptions, than you would expect for a reciprocating engine. And when we hover over the dot here that refers to this project, we see that it's using flare gas. So essentially it benefits from free fuel. Fuel that would natural gas that would otherwise be flared is being used as fuel for this project. So if we can control the initial cost of construction, this potentially could be a very low-cost energy provider. Another really low-cost energy provider here is the Shepard 1 combined cycle gas turbine. So a really large project that operates really efficiently and benefits from the cheap cost of gas in Alberta. So yes, it potentially has low energy production costs. Comparing hydro, wind, and photovoltaics, we see that somewhat surprisingly for many, I would expect, photovoltaics and wind turbines don't look that bad compared with hydro turbines in terms of the energy production cost. And that reflects the reality of Alberta right now that there's a lot of interest in photovoltaics and wind turbines. Next, I will look at performance analysis. Here are the 4 questions I'm going to focus on are, what are the capacity factors of the different technologies? So that is, how much electricity do they produce on average per unit of installed capacity? Which projects or technologies are providing the largest quantities of electricity within this portfolio? What is the performance advantage of solar tracking, if any, compared with fixed mount systems? And then what is the seasonal variation in wind power production in Alberta, particularly to investigate whether it's complementary to the seasonal variation in solar generation. We know that we can expect less electricity production in winter from solar than in summer, but how does this compare with wind? Is wind complementary to this in terms of producing power in the seasons when photovoltaics is producing less power, or does it also exhibit the same tendency? So here I'll be looking at the performance analysis sections here and opening the technology type here. I can see there's already a specific energy production by type. So this isn't the capacity factor, but it's directly proportional to the capacity factor. And I see for 2021, which is a year for which I'm sure there's a full year's data for all the projects, including the solar projects, which have been built more recently. I can see that the highest energy production in terms of megawatt hours per installed kilowatt of capacity is coming from this reciprocating engine. You'll recall that's the flare gas project. So this stands to reason. If you're getting free fuel, you're going to want to operate that as much as possible because it's the initial costs that are the major costs associated with the project, not the fuel costs. So it stands to reason that this would operate a lot and generate a lot of electricity per unit of installed capacity. Similarly for the gas turbine combined cycle, right? A combined cycle gas turbine, highly efficient, benefits from cheap gas. You're going to want to run that as much as possible. In contrast, we see that the simple cycle gas turbine in green here has a very low capacity factor. It has high operating costs and it's only going to be run as a peaking plant. So it's going to only be operating when the cost of electricity is really high. So it has a low capacity factor or low energy production per unit of capacity. Photovoltaics in red here also has a relatively low capacity factor, largely because the sun does not shine all the time, as we all know. But somewhat surprisingly, it's not that different from hydro. So we tend to think of hydro as being a technology that's going to have a higher capacity factor than photovoltaics, but in these projects, it's not actually the case. In contrast, wind here has a capacity factor about twice as high as that for photovoltaics. In terms of the quantity of electricity being produced by these projects, we see that the biggest contributor, at least in recent years, has been our combined cycle gas turbine. So a really big project that operates with a high capacity factor, it's going to generate a lot of electricity. The steam turbine projects in blue here are also historically major contributors. Over time, we've seen the contribution of wind in light blue ramp up over time. And initially, it produced less electricity than the hydro projects, but recently it's produced maybe twice as much. The red bars, which are for photovoltaics, and the green bars, which are for the simple cycle gas turbine, are barely visible, indicating their contribution, at least currently, is fairly minimal. The next thing we might want to look at is in a little bit more detail on our photovoltaic systems here in terms of their capacity factors for solar tracking systems. So do we see the benefit from solar tracking that we would expect to see? So looking at 21 data, I see that there are two projects, this Hull Solar and Vauxhall Solar projects that have high capacity factors or capacity factors of around, say, 19 to 21%, and two that have lower capacity factors, Innisfail and Brooks, at maybe 16 to 18%. So I can look at some other graphs that are available here, where we break down the photovoltaics projects by whether they're single axis tracker or full fixed ground mount systems. And if I look at the capacity factor there, I can see that indeed the Hull Solar and the Vauxhall Solar projects are single axis tracking systems. So we see higher capacity factors, as we would expect to see with the tracking systems. They're at about 19 to 21% versus 16 to 18% for the fixed ground mount systems. So that's consistent with our expectations. We can also look at the capacity factor in terms of monthly data here for those same four solar projects, and two things stand out. One, we see that the capacity factor for these tracking projects is significantly better than for the fixed ground mount systems during summer, but there's fairly minimal difference during winter. And this also makes sense. The sun tracks a longer arc in the sky during summer than during winter, when it tends to be low on the horizon towards the south. So tracking has more potential benefit in summer than during winter. The other thing that stands out is the extreme seasonal variability, where we have very little electricity generation during winter, but a lot during summer. And we might ask the question, well, how does that compare with wind? So we go to wind turbines here, and we look at our wind turbines in terms of their monthly capacity factor. And we see that to a certain extent, they are complementary. Here, the lowest electricity production is for June, July, and August, and the highest is in the winter months and the autumn months. We also see there's considerable variation in the capacity factor from one wind project to another. So in green, for instance, here, we see low capacity factors, particularly in the windiest months, and that's that Bull Creek #1 project that we identified as having a high electricity production cost in the benchmark analysis. Finally, let's turn to feasibility analysis here. And I'd like to remind you, now we're not talking about real projects. We're talking about the hypothetical situation where these were not yet real projects and we're contemplating whether we should build them. So we're using assumed values for costs, for value paid for electricity, not data from the actual projects. We're combining that with their actual performance, but not their actual costs. So from this point of view, we'd be interested in examining which projects would generate the highest revenues, which would be the most profitable in terms of their IRR and net present value, which projects would have the lowest greenhouse gas emissions reduction costs. This is of increasing importance for many companies. They're looking at how to reduce their GHG emissions, and they'd like to do that in the cheapest way possible. What are the expected annual revenues per kilowatt of installed capacity for wind projects in Alberta? So this is an example of a little bit of a more detailed question that can be examined through this portfolio. And finally, let's circle back to Brazeau Hydro and figure out through the feasibility study why it has such high energy production costs, as we identified it as an outlier in the benchmark analysis. So here I'll be looking at the feasibility studies here. I'll start with looking at electricity export revenues for all projects here. And I can see that the projects that stand out are the combined cycle gas turbine, which has really high revenues, maybe almost 350 million per year. This large coal-fired power plant here, this coal gas-fired plant here, and the largest of our wind projects, the Black Spring Ridge wind project. So those are the ones with the highest revenues. In terms of profitability, we can turn to the internal rate of return and then later the net present value. So looking at the internal rate of return, 3 projects stand out. Once again, this combined cycle gas turbine project, which has an internal rate of return of, say, a little over 30%. Even higher internal rate of return is associated with this reciprocating engine that's using free flare gas. It has an internal rate of return of 33%. And then this coal gas steam turbine project has a nearly 30% internal rate of return. And we can understand why these might be the projects that might have a good internal rate of return, assuming we have reasonably controlled initial costs. The combined cycle gas turbine has high efficiency and makes use of cheap natural gas, so it could be profitable. The reciprocating engine gets free fuel, so that could lead to a very profitable project, assuming the initial costs can be controlled. And this coal gas steam turbine project is actually a project that used to run on coal, but could no longer do so in part due to government regulation. So the actual initial cost of the project is not the entire cost of building this power plant, but merely converting it so that it can operate on gas. So for a relatively modest investment in terms of this conversion cost, you can have a power plant, a large power plant that makes use of cheap natural gas to generate power. So that potentially could be very profitable as well. Now, if we were only able to build one of these projects and we looked at the IRR, we might be tempted to say, well, this West Cadott flare gas project has the highest IRR, so that's the one to pick. But that points out a pitfall of using the IRR as opposed to, say, the net present value, which is that would you prefer to invest in this reciprocating engine project, which has a high, very high IRR, but a very low level of investment, or would you prefer to have an investment in this combined cycle gas turbine, which has a pretty good IRR, but a huge level investment? And naturally, you would like to earn a good IRR on a big investment rather than a slightly better IRR on a much smaller investment. And that pitfall is avoided by looking directly at the net present value here, which is essentially, how much these projects are going to make you richer over the long term. And here, that combined cycle gas turbine stands right out as being the most profitable project if you have to invest in a single project. Of course, profitability is not everything. Greenhouse gas emissions reductions are increasingly important. So looking at the greenhouse gas emissions reduction cost, somewhat surprisingly, a winner here as well is the combined cycle gas turbine. And some of you may be questioning that, saying, listen, how can burning natural gas be better than some of these renewable alternatives, at least from this perspective? Well, one thing, under these set of assumptions, it's a highly profitable project. So that reduces its cost, right? A profitable project has negative costs for GHG emissions reductions. Second, you need to keep in mind what our base case is. And our base case is the Alberta grid, the mix of generation on the Alberta grid. And that includes coal-fired generation. So if you're comparing combined cycle, highly efficient gas generation with a grid that contains a fair bit of coal, yeah, the emissions are going to be lower with your highly efficient gas generation. So it's going to generate emissions reductions compared with the existing grid, which contains coal. And that's why we see an attractive GHG emissions reduction cost here, negative cost for GHG emissions reductions. However, some people will prefer to stick with renewables, for example, and there they might want to pick out low-cost renewables. So Brazeau Hydro is definitely not a good choice here, right? At over $500 per ton of CO2 emissions reductions, it's the most expensive one here. In contrast, we have some wind and solar projects that don't look too bad. So that Black Spring Wind project here, for about $40 per ton, at least under this set of assumptions, and I would assume that in reality, it's actually much lower than that. I would assume it's actually a profitable project, would have negative costs associated with it. But under this set of assumptions, it's a positive cost for GHG emissions reductions. That would be one that stands out. The Bull Creek, on the other hand, is not so attractive, as we saw earlier. You'd prefer to go with some of these solar projects, like the Vauxhall Solar Project, as an example. We can investigate things in more depth as well as getting these broad overview questions answered. So one thing we might want to look at is wind turbines and just come up with an answer to the question of, if I install a kilowatt or a megawatt of wind capacity in Alberta, what can I expect in terms of annual revenues? And I can find that in this chart here, which compares our different wind projects in terms of their annual revenues per kilowatt of installed capacity. So I can quickly answer this question. It's going to be about, under this set of assumptions, about $100, $200 per year per kilowatt that we install. So we can see the range of variation, and we can answer that question that way. And finally, I want to return here to the portfolio page to remind you that you can use this as a way to launch the individual .retx files. So let's go back and look at this Brazeau hydro project by double-clicking on it and see why it's such an outlier in terms of energy production cost. So I turn to the energy page here, and I'll first look at the electricity and fuels and see that it's got a really low electricity export rate. So it's assumed that only 5.6 cents per kilowatt hour is being paid for the generation from this project. So we're ignoring other potential benefits, such as capacity benefits or grid support, and only looking at the Alberta power pool price of electricity, which has been really low recently. So that may not reflect reality. And then if we go to the analysis of the technology itself, we see that it's a really big project, 350 megawatts. In fact, in the notes section here, we see it's the largest hydro project in Alberta. So it's really expensive, about a $1.3 billion investment if we were to build it today, but it only has a capacity factor of 10%. That's what we see in the performance data. So yeah, if you're investing $1.3 billion, but only getting annual revenues of 17 million because you're operating with a low capacity factor, that's not going to result in a low energy production cost. However, the reality is this project is not something we're contemplating on building now. It was actually built almost 60 years ago. So the initial investment has been paid off long ago. And really what we're concerned about is the comparison of the electricity export revenue and the O&M costs. And we can see that even at a 10% capacity factor, it would be interesting or advantageous to continue operating this plant because the revenues well outweigh the operating costs. So just to sum up here, in conclusion, RETScreen's portfolio functionality is not limited to buildings. You can also use it to manage power projects. And to demonstrate this, future versions of RETScreen in the near future will have an example power projects portfolio built in. And that will include examples of benchmark analysis, performance analysis, and feasibility studies. Thanks very much for this opportunity to present the power portfolio to you.
Thank you, Michael, and thank you to all our presenters. This concludes Session 2, Feasibility Analysis with RETScreen Expert. Thanks for watching.